Detecting duplicate items in a list is a problem you tend to run into quite often, and there are many ways to solve it, from direct to optimized. This problem has the following list of 8 elements. I have two constraints. First, no number in the list, the little owl indicates a list item, can have a value greater than the size of the list itself, which here is 8. Second, find all the numbers being repeated twice only. The trick in this question, as with most of these type of questions, is given through the constraints. It says that all numbers in the list will be equal to or lesser than the size of the list. So if there are 8 elements, I will only have the numbers 0, 1, 2, 3, 4, 5, 6, 7, and 8, which luckily is all the positional markers of a list. So I'm going to make another list with an exact same size and make all the values and all positions equal to 0. Then I'm going to loop through or go through each item in my list. Every time I see a number, I'm going to find its index, the blue boxes, and increase that by 1. I'm keeping count of the number of times a certain number repeats. Note that 4 is the 4th element in the output list, but it will be at index 3 since we start from 0. As I'm moving through this, I add a count to its location in the output list and move on. When I see 3, I add 1 to the 3rd location in the output list. When I see 2, I add 1 to the 2nd location in the output list. When I see 7, I add 1 to the 7th location in the output list. I see 8, I add 1 to the 8th location in the output list. I see 2 again, I add 1 more to the 2nd location. I see 3 once again, I add 1 more to the 3rd location. And finally, I see 1, so I add 1 to the 1st location. In the end, I print out the list, the second list, and I know which indexes had duplicates, and I can do unspeakable things to them. Here's the code for this. I make 2 lists, same size. I loop through one, then add a 1 to the value at the second list position when I come across the number of this list position in the first list. That was a mouthful, so I urge you to solve this by hand and make sure you get the correct sequence of events. How about a more advanced way that reduces space or time complexity? Yes, you remembered right. We are talking about the algorithmic complexity from way back then. We will use the same array and a much smaller list, which is initially empty. How do we do this? By using a minor trick with multiplication and absolute value. Remember that the absolute value operation gives you a positive number, whether you feed it negative or a positive number. As I'm moving through this, I multiply the location where this number comes by a -1. So 4 will be the 4th element at list index 3, or the 4th position because of the 0 effect. And we make the value sitting at index 3 a negative number. Notice this little red flag I put here. This is to indicate that this number representing this location, 4 at index, has already been seen. These flags will prove handy soon enough. Don't worry, this will not mess up anything, as we will be using the absolute value operation, or the positive value of every number will be gotten because of that. So we don't run into any negative indexing problems. When I see 3, I go to its list location at index 2, or the 3rd position in the list, and multiply that by -1, which makes it 2 negative, and we put a flag here. When I see -2, I go to its absolute value list location at index 1, and I multiply that by -1, which makes it 3 negative, and we put a flag here. When I see -7, I go to its absolute value list location at index 6, and I multiply that by -1, which makes it 3 negative, and I put a flag here. When I see 8, I go to its absolute value list location at index 7 and multiply that by -1, which makes the 1 negative, and I put a flag here. Now I'm seeing that the 2 is repeated. I go to its absolute value location at index 1, and before I multiply that by -1, an alarm goes off because there's already a flag here, which means it was negative before, telling me that I will be doing multiplication by -1 twice. This means that 2 was repeated, so I add 2 to my output list and leave the flag untouched. Now again, I see 3 repeated. I go to its absolute value list location at index 2, and before I multiply that by -1, an alarm goes off because there's already a flag here, which means that it was negative before, which sets off this alarm, telling me that I will be doing multiplication by -1 twice. This means that 3 was repeated twice, and so I add 3 to my output list and I leave the flag untouched. Finally, I get to the last element. When I see 1, I go to its absolute value list location at index 0 and multiply that by -1, which makes the 4 here negative, and I put a flag here. After all this, I have a much smaller list containing the duplicates of 2 and 3 only, and the original array or list with some negative flags. Question: how do you think we set the alarms which alert us when a duplicate is detected? Conditionals, your if-else, of course. Let's see how this looks like in code. We want a condition to be satisfied here, which is what we're checking for. A flag or a negative number already exists. It is a symbol check. We see if the number at an index that we're looking up is already negative or less than 0. If yes, that means that we did the multiplication by -1 earlier, so this second round is for a duplicate of the same number that gave us this index. This might seem a little confusing, but once again, redo the approach yourself by hand and then compare the answers with the code. If you're going for coding interviews, this will be a bread and butter. Coming up with a solution that works, we call this brute forcing, and then fine-tuning it to save either space or time complexity.